Hello, my name is Emily File, and I will be doing a presentation on homocystinuria today for genetics at Doane University. Let's talk about the history of homocystinuria. First of all, what is homocystinuria? According to a revisit to the natural history of homocystinuria due to cystathionine beta synthase deficiency, homocystinuria was first described in 1962 in a search among mentally retarded individuals in the discovery of cystathionine beta synthase deficiency as a causative enzymatic deficiency followed shortly thereafter. What this means is that it is a disorder where humans are deficient on this certain enzyme, which causes their body to develop a small variety of issues, which we will soon follow up with. The major geographic focus of this genetic deficiency happened in Denmark and other regions of the European countries. The article also states that in great efforts to understand the history of this genetic mutation, they did a major survey from 1981 to 1985. During this survey, they researched almost 600 cases that had been prevalent over this period. They took a large quantity of cases and began to test for that certain CBS gene that shows when a human is deficient for that certain enzyme. They found ways to clone, sequence, and now over 140 mutations have been identified to relate to this genetic disorder. They have discovered how to test for this enzymatic deficiency in the plasma of blood in present day. A description of the genetic disorder is homocystinuria is a genetic mutation which can result in symptoms such as mental retardation. This doesn't mean that it only shows mental retardation. There are different forms. According to the U.S. National Library of Medicine and National Institutes of Health, characteristic phenotype signs of homocystinuria are mental retardation, ectopia lentis, thromboembolic episodes, and osteoporosis. I'll follow up on what these exactly mean in just a moment. This enzyme deficiency can affect multiple body systems. The ectopia lentils, which are in the eyes, is also known as severe myopia. Myopia is where you cannot see far away, and so it's commonly known as nearsightedness. Thromboembolic episodes are located in the cardiac system, which is affecting your blood clotting in the veins. Then, homocystinuria affects the skeletal system with osteoporosis, which basically means the weakening of bones. It's more common in the elderly population, and it's also common in women while they're going through menopause. Although the article given states that the addition of vitamin B6, or also known as pyroxidine, can slow the rate of metabolic abnormalities caused by this genetic mutation, or known as homocystinuria. Previously, I mentioned what bodies it affected, so some of the major characteristics are myopia, or nearsightedness, dislocation of the eye lens, glaucoma, and weakening of the bones, or osteoporosis. It does affect many different systems, and you can refer to this image on the right to see the breakdown of homocystinuria as a word. Homocysteine is a I'm struggling to say these words, metabolite of methionine, and urea means a substance in the urine. And so when we say this word, it basically means a lot of homocysteine in the urine, and it gives a list of the body systems previously mentioned that it affects. When we speak about prevalence, according to the previous article that I mentioned, a revisit to the natural history of homocystinuria due to cystathionine beta synthase deficiency, prevalence is at the present time undetermined. There are newborn screenings and clinical ascertainment underestimate the prevalence because of undetected cases. So unfortunately, the prevalence of cystinuria or homocystinuria is hard because It shows up in a wide variety of ages, from ages 18 to 65. It can show up in kids, and it's hard to discuss the prevalence because it's not just broken down to a certain age range. The molecular cause of this disorder, the responsible gene for the genetic mutation is called CBS, or cystathionine beta synthase. This enzyme is dependent on vitamin B6 in the body, and according to another article called Homocystinuria caused by cystathionine beta synthase deficiency, the one that I previously mentioned, this chromosome is specifically located on 21q22.3 in the CBS gene. When we talk about the mode of inheritance, that article that I've been referencing multiple times, it is specifically an autosomal recessive manner. It's a CBS deficiency, and it is recessive in the way that it comes from the parents, and I will go more into detail with the Punnett squares and the pedigree that I will soon go over with you. So when we look here at a Punnett square, we have two parents. Both are carriers because one has a bigger H and one has a lowercase h. When we think about autosomal recessive, when the offspring has those two lowercase h's, the two recessive letters, that means that that offspring is afflicted with the homocystinuria. So when we look at this two carrier parents who have 4 offsprings, there's a 25% chance that their offspring will be affected. There's a 50% chance that their offspring will also be carriers. And there's another 25% chance that they'll have both the uppercase H's or dominant and not be afflicted at all with the disorder. And then when we look at this pedigree, we see 2 grandparents, John and Mary. They end up having 4 kids, Greg, Kathy, Jenny, and Steve, who end up getting married. And you can see that it's autosomal recessive because those first 2 generations are not affected, but they end up having kids who are affected. So that means that these parents that were unaffected in what our pedigree looks like were carriers because they ended up having offspring who were affected. So when we talk about options for genetic testing, homocystinuria is not classified down to a certain gene always because there are so many different types of homocystinuria, the way that affects the eyes or the bones. And so there are different tests. And so I just brought up 2 main tests that I found available through my own research. And so one of them is called the Baby Genes Targeted Panel, and that is testing for sequence analysis of the entire coding region. And then another test was, I'll just call it MRD. I can try and say this name, but it's methylene tetrahydrofolate reductase deficiency. I'm sorry if I butchered that, but it's a different type of test that will basically look for mutations in the entire coding region and sequence analysis of select exons. So it's looking over the genetics in that certain DNA sequence to look for mutations that are leading towards homocystinuria. Testing for this disorder isn't mandatory because a lot of the times the symptoms are going to develop over time in an offspring because, like I said before, it's very random when it shows up. It doesn't just show up in a certain age range. It can show up in late adulthood. It can show up in early adulthood. Every person is different with how they exhibit symptoms for this specific disorder. However, usually testing is done after the child is born. For the first test, they do it in the side of the cheek called a buccal swab. They can also do it on the cord blood or a dried blood spot. For the other test, the MDR test, it's also a possibility that they can do it through amniocentesis, where they take a needle and stick it into the mother's belly while she's pregnant and check for inside that fluid to see if they're possibly affected. And they can also do it by buccal swab or saliva or blood as well as the other test. Some companies that offer this are Clinical Molecular Genetics Laboratory at Johns Hopkins Hospital and Baby Genes by Archer diagnosis clinical services. So I listed the links to the websites here so you can go there and you can do more research if you are interested in testing. It is important to get tested if you are feeling like you're having these symptoms because you want to stop the osteoporosis and stop the weakening of your bones as soon as possible if you are affected with this disorder. And these are all my references. If you have any questions, you can always email me at emily.file@doaneuniversity or doanedu.edu. Sorry. Thank you, everyone.